Okay guys, let's review for quiz 1B, the power rule and scientific notation. So power to a power, we're going to multiply our exponents. So when we have a power raised to another power, we can combine the exponents. Instead of having two, we can have a single exponent by multiplying. So here we have x, and it's 0 times 2, the outside exponent times the inside, and we get x to the 0, which we know is 1. On our next example, we have 2 to the first, m to the second. We're going to take this 3 and we're going to distribute to all the exponents inside. So we have a 2, we have an m. So we're going to have 2 to the third and m to the sixth. Now we can evaluate 2 times 2 times 2, which is 8, times m to the sixth. Our next example, we have a k to the third and an n to the second raised to the fourth. So I have a k and I have an n. So when we multiply each exponent by 4, we get 12 and we get 8. And everything's positive. On our next example, d has an exponent of -2 and e is raised to the first, all raised to the power of 3. So I have a d and I have an e. 3 times -2 is -6. 3 times 1 is 3. Now we need to move d to the -6 to the denominator, and e to the third stays where it is, and put a 1 in our numerator. On our next example, 2 has an exponent of 1, x to the -2, and y to the third, all raised to the fourth power. So we have a 2, we have an x, and we have a y. So when we distribute the 4, we get 4 on the 2, -8 on the x, and 12 on the y. So we need to evaluate 2 to the fourth, which is 16. We need to move x to the -8 to the bottom, making it a +8, and then y to the 12th stays in the numerator. On our last example, we have a 3, an a, and a b, and we are distributing this 3 here. So 3 times -1, 3 times 4, and 3 times -2. Now we need to bring the 3 to the -3rd to the denominator. We'll go ahead and evaluate 27. A to the 12th stays where it is. B to the -6 is going to flip to the numerator and become a +6. Here we have some scientific notation, or some sort of scientific notation, but it's not proper because our coefficients need to be between the numbers 1 and 10 without going over 10. So 0.34 is not between 1 and 10, so we're going to increase this by moving the decimal 1 time. So I increased my coefficient, so we need to keep it balanced by decreasing our exponent by 1. So we have 10 to the 5th. Our second example, 72.1 is too big, so we need to decrease it to 7.21. So we move the decimal once, so we need to increase our exponent of 2 to a 3. In our last example, 0.02 is too small, so we need to increase it by moving the decimal twice. So I increase it 2 times, moving the decimal twice. So we need to decrease our exponent by 2. So I decrease -8 to -10. Okay, let's write these in scientific notation. Here, our coefficient is going to be 9.71. That's between 1 and 10, times 10 to the, and we move the decimal, it was originally at the end, 1, 2, 3, 4, 5, 6, 7. We moved it 7 times. In our next example, we have a small number. Our coefficient is going to be 3.21 times 10 to the negative. So we moved our decimal 1, 2, 3, 4 places to the right. So we have a negative exponent. Our next example is going to be 5. That's between 1 and 10 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And our last example, We're going to move the decimal until we have 6 because that's between 1 and 10, times 10 to the negative 1, 2, 3, 4, and 5. Make sure you move it past the 6. Okay, let's convert these to standard form. So I'm going to have a small number because I have a negative exponent, so I'm going to be moving the decimal to the left. So I'm going to write out 803, leaving room in front. So the decimal was here. I'm going to move it 1, 2, 3, 4, 5, 6. So remember, your exponent is how many times we move the decimal, not how many zeros we have. Our next one, we have a large number because our exponent is a positive. So I'm going to write down my 9 and 9. So we're going to move it 1, 2, 3, 4, 5, 6. 1, 2, 3, comma, 1, 2, 3, comma. Our next example, we have 2, the decimal's here. We are going to move the decimal to the right. So I'm going to move it 1, 2, 3, 4, 5. And our last example, we're going to move the decimal to the left because it is a negative exponent. So the decimal is behind the 3. So I'll move it 1, 2, 3, 4, 5. Okay, now let's multiply scientific. So remember, multiplying scientific notation is like multiplying variables. If I have 3a times 2a to the second, we multiply the coefficients. 3 times 2 is 6, and we combine the like bases by adding the exponent. So it's the same here. We're going to multiply our coefficients. 6 times 3 is 18. We are going to put the power of 10 and add exponents, apply the product rule, and get negative 7. 18 is too large, so we have to decrease it by moving the decimal once. Our coefficient is 1.8, so we must increase our exponent of negative 7 to negative 6. Now we have 4.3 times 1.1. So let's multiply this out. 1 times 3 is 3. 1 times 4 is 4. Put our 0. Multiply by this one. 1 times 3 is 3. And 1 times 4 is 4. We're going to add 3 plus 0, 4 plus 3, and 4. Our decimal is 1 and 2 spaces, so 1 and 2. So we have 4.73 times 10 to the, we're going to add exponents to the 10th. 4.73 is between 1 and 10. I'm good to go. Now we're going to divide. So this time we are going to divide our coefficients and then use the product rule and subtract our exponents. So 8 divided by 2, top is in the box. 2 divided into 8 goes 4 times. So our coefficient is 4 times 10. We're subtracting negative 3 minus, be really careful here, negative 5. Negative 3 minus negative 5. So we do keep change anytime we're subtracting, not when you're adding, just subtraction. So keep change gives me positive 2. 4 is between 1 and 10, so I'm good to go. On our next example, we're going to divide 2 into 3.6. So we put the top inside the box, top in the box. Whoops, let me erase that. So we're going to divide 2 into 3. That goes 1. 1 times 2 is 2. Subtract, bring down the 6, and 2 into 16 is 8. So we have 1.8 times 10, and it is 7 minus 2, which is 5. Our coefficient is good, so we are finished. When we're adding and subtracting, we're going to convert to standard lineup decimals and then convert it back to scientific. So 9.4 is times 10 to the 5th is really, here's our decimal. We're going to move it 1, 2, 3, 4, 5. When we have the 3, we're going to move the decimal 4 times. So we're going to be adding 4 zeros to the end. And again, my decimals are lined up. We add 0.000079. So now we convert it back to scientific. 9.7 is my coefficient times 10 to the 1, 2, 3, 4, 5. We're going to subtract. So we have 7, and we're going to move it 4 places. 1, 2, 3, 4, minus our 8.1. We're going to move it once and then add 2 zeros, and that will be a total of 3 decimal moves. So the decimal was here, and we moved it 1, 2, 3. So we're going to subtract 0, 0. We can't take 1 from 0, so we're going to borrow and make this a 10. And then we have to borrow from the 7, make that a 6, and this becomes the 9. So 1 from 10 is 9, and 8 from 9 is 1, and 6. So we're going to have 6.19 times 10 to the 1, 2, 3, 4, positive 4. Let's do a couple more. So this time we have some very small numbers. And so I have 9.4. I'm going to move the decimal 1, 2, 3, 4, and 5. On this one, again, we're going to line up decimals. So I'm going to move the decimal once and then add 3 zeros in front. And we are adding. If you want to put some zeros here, you can. So I have 4, 9, 3, 0, 0, 0. So I have to be careful, really neat here. I got a little messy, and I think this is correct. So I'll combine those. Yes, I have to be very neat here. Scientific notation, 3.94 times 10 to the negative 1, 2, 3, 4. And our last one. So we have 7 times 10 to the negative 4. So we're going to move the decimal to the left. And so that's going to give us 3 zeros. So I moved it 1, 2, 3, 4. And then I have 8.1. I'm going to move it once and then add 2 zeros. And then we are subtracting these. So I'm going to line up my decimal. And I can see that I can't take 8 from the 0. So I'm going to flip this around. And I'm going to have 0, 0, 8, 1. And we're going to subtract 0, 0, 0, 7. Okay, now we're subtracting in this order, so our answers end up going to be negative. Okay, so this is the negative here. So when I subtract, I can't take 7 from 1, so I'm going to borrow and make this a 7, and this is 11. So 7 from 11 is 4. 7, 0, 0.0. And that ended up being negative because we have more negatives. Okay, and then we're going to convert it to scientific. So we moved it 1, 2, and 3. And I'm going to put my little negative out here. And I hope this helps.